for another video. So hopefully you can see this. I've been having some problems with the focus. But anyway, this is going to be the first video in a series about solution chemistry. So to start off with a discussion about solutions, we got to start off by talking about concentration units. So a solution is any time you have two things mixed together evenly. Generally, we're talking about homogeneous solutions. So all of our bits and particles are distributed evenly throughout our solution, kind of like my drawing here, where you can see I've got my solvent, the thing that is doing the dissolving. My liquid, the universal solvent, is usually considered to be water. Then I've got my solute, my little particles that are dissolved in my solute, or excuse me, in my solvent. So our solute could be things like sugar, salt, anything you like. It's the thing actually being dissolved. The liquid in which it is dissolved is called the solvent. So it does the dissolving. I'll spend another video talking about the actual solvation process, but for now we'll just suffice it to say that my solvent can pull apart or suspend my solute molecules in order to create this evenly distributed solution. What this means is that it doesn't matter where I sample from. If I sample from this corner of my container or this corner, it doesn't matter. It's going to have the same concentration. So if I say that if I sample from here, I got 25 milliliters, it doesn't matter. It's still a 3 molar solution, for example. This one over here would also be a 3 molar solution. So the concentration is the same throughout your substance. It does not matter where you sample from, or from which you sample. Use proper grammar there. So the first concentration unit that I want to discuss is probably the most common, and it's pronounced molarity. It's represented by a capital letter M, and molarity is calculated by dividing, can you see that through that light bulb thing right there? There we go. That's calculated through the moles of solute divided by the liters of solvent. And it does have to be moles, and it does have to be liters. What this means is anytime you see this capital M symbol, like this here, this 1.2 molar solution can be rewritten as 1.2 moles per 1 liter of solution. So these two expressions are equal. So 1.2 M NaCl would be read as a 1.2 molar solution of sodium chloride. And again, I can expand this 1.2 molar into 1.2 moles per 1 liter of solution. That's what's going to come in handy with some of our examples later on. So our first example down here towards the bottom, as far as what problems might look like, says find the molarity of 25 gram sodium oxide dissolved in 300 milliliters of water. So my 25 grams of sodium oxide here is my solute. It is the thing that is being dissolved. My 300 milliliters of water is my solvent. They asked me for molarity, which we know is moles per liter. Well, I have neither of those units just yet. All I have at this juncture are grams and milliliters. Doesn't help me too much. So the first thing we need to do is to convert this from grams into moles. To get from grams to moles, I need the formula mass of this compound. So I'm going to go ahead and set up my conversion here. Let me see. Let's calculate that formula mass there. 22.99 times 2 plus 16. There it is. Grams per mole. 25. So 25 divided by that formula mass. Whoop, you can't see that. Can you see that? Sort of, kind of. There it is. So there's my moles of sodium oxide. Ooh, my battery's gonna die. Second one there, I need my liters. 300 milliliters. We have 1,000 milliliters per 1 liter. So that's 0.300, oops, liters. I got moles, I got liters. Let's go plug them into our formula over here. So we get 0.40336 moles divided by 0.300 liters. There's our molarity. That bright light in the middle there is just a problem. How many sig figs can I have? We're going to say 2 is probably good. So that's a 1.3 molar solution of sodium oxide. Remember, your final answer needs to have correct sig figs. It also needs to have the number, the unit, and the thing. So this is a 1.3 molar solution of sodium oxide. Whoops. So that's your basic problem. But this next one is the sort that you might see in a lab situation. It says how many grams are needed to make a 1.5 molar solution of ammonium sulfide. So in a lab, this might be something that you're asked to do, is to make a solution of a particular concentration. Now, when I wrote this problem, I left out a little useful piece of information. We need a volume. There we go. I make up most of these problems off the top of my head, so sometimes I don't realize my mistakes till I read them again. All right. How many grams are needed to make 150 milliliters of a 1.5 molar solution of ammonium chloride? So, in your labs, it tells you that you need 150 mils of a 1.5 molar solution. You need to make this. So that means you're going to use 150 mils of water. How much of this ammonium sulfide do I need? Well, we said that molarity, wrong color pen. This number here can be expanded out to 1.5 moles per 1 liter. Well, I don't have 1 liter of solution. I've only got 150 milliliters. So we're actually going to start doing a conversion to figure out how many grams I need. So ultimately, I got to get to grams. So we're going to start off the problem with the bit of information that applies specifically to my lab. 150 mils of my solution. Well, we know that molarity, is moles per liter. That's not liters. So, first conversion factor we need to do is to convert to liters. All right, that's much better. Now we're trying to get from liters to something related to grams. Well, we know molarity is moles per liter. Hey, that sounds like a conversion factor that could link those two things. So this is the same thing as 1 liter, 1.5 moles. So there it is, 1.5 moles per liter. This right here is my molarity. But we're not finished with that yet. My problem didn't ask me for moles, it asked me for grams. That last step to get from moles to grams requires the formula mass. So let's see, ammonium sulfide, how's that written? NH4,2S, yeah. So that's 2 nitrogens, 8 hydrogens, and 1 sulfur. Gives me a formula mass of 68.17 grams. Multiply all the way across the top, divided by all the way across the bottom, and I find that I need to weigh out 15.3 grams of ammonium sulfide. Once I dissolve that in my 150 mils of water, then I have my 1.5 molar solution. So these problems are effectively a game of where do I start, where do I want to go. They started me here with milliliters, they wanted me to get to grams, and then all of my intermediary steps were just pieces to the puzzle to get me there. The next video will cover molality, the next of our concentration units. See you there.